Okay, on this one we're going to take a look at numbers 33 through 37. So 33 jumps in here with a right triangle problem where we have a camera man that is standing 750 meters from a launch pad for a space shuttle, and this space shuttle is going to be going straight up and down right here. And so what that gives us when he's looking up at it is a right triangle. So anytime I'm working with a right triangle, I can go back and use SOHCAHTOA. Alright, this right here then is 1200 meters, and it wants to know what's the angle of elevation. The angle of elevation is always the angle from the ground looking up, so I'm going to call that angle right there theta. Alright, so I'm given information on my opposite side and my adjacent side. So opposite and adjacent tells me to use tangent. So that'll be the tangent of theta is equal to my opposite over my adjacent. And this is why they threw this one in right here, because to get that tangent over to the other side, we're going to use an inverse. And I'm not going to do a lot of simplifying on that fraction right there because I'm about to put it all into my calculator anyways. Alright, so in your calculator, first of all, check and make sure that you're in degree mode for a question like this. We'll work in degrees. And I'm going to put in second tangent, and I'm going to work with 1200 divided by 750. And it doesn't tell me where to round to on this one, so I'll go ahead and round to 3 decimal places. 995, and we're working in degrees, so don't forget your degrees symbol right there. Okay, on 34 we get into working with some of our identities. So let me just remind you about a couple of our identities real quick. First of all, we have our reciprocal identities. Choose theta, so cosecant is going to be 1 over sine, and secant is going to be 1 over cosine, and cotangent's 1 over tangent, but I really prefer to talk about tangent in terms of sine over cosine and cotangent as cosine over sine, like that. And then our last ones that we work with are our Pythagorean identities. So sine squared plus cosine squared equals 1. I switched over to a variable of x now instead of theta, but they all mean the same thing, so you can use either one. I've also got 1 plus tangent squared equals secant squared. And then I've got my 1 plus cotangent squared is equal to cosecant squared. So all of those identities that would be good to know for the exam. Alright, so on number 34, I want to simplify one of these. So I've got that sine x is equal to sine x, plus cotangent x times cosine x. And I just want to get this in its simplest form. So let me start by changing everything into terms of sine and cosine. So I'm going to put this cotangent right here as cosine over sine, and then I've still got a times cosine. Right, next let's do a little algebra. So I'm going to say cosine times cosine is going to give me cosine squared, and I've got that over sine. All right, now I need a common denominator to be able to add these together. So a couple of ways to do common denominator, but what I like to do is called SMILE. So I'm going to multiply these together right here. That gives me sine squared. I'm going to use the sign that's in between. I'm going to multiply these two together right there. That gives me cosine squared. And then on the bottom, I'm going to multiply these together. There's my SMILE right there. And that gives me sine. Right, so up there on the top, we just said that sine squared plus cosine squared is equal to 1. So this is going to give me 1 over sine, and I know 1 over sine is cosecant. And that's the simplest form that one can be in. All right, we've got a real similar question on number 35. I'm going to do something real similar and find that common denominator. So let's use SMILE again for that. This time they're using theta and 1 plus cosine plus cosine over sine, which I could change into cotangent, but I'm going to leave things in terms of sine and cosine because that's kind of usually my first step anyways. So let's just add these together. So common denominator, again, I'm going to use SMILE. So sine times sine gives me sine squared. And all of this times cosine, I need to distribute. So cosine times 1 gives me cosine, and cosine times cosine gives me cosine squared, And then on the bottom, I'm going to have 1 plus cosine times sine. And I'm going to keep those separated for just a minute. You'll see why in just a second. I'm keeping those separated, but I'm going to go ahead and keep those separated out. All right, then I know that sine squared plus cosine squared is equal to 1. So I'm going to take this sine squared plus cosine squared right here, and I'm going to make that equal to 1 plus cosine theta. And I've still got 1 plus cosine on the bottom. And I've got that times sine. Now, since these two things are multiplied together, I can let this 1 plus cosine and this 1 plus cosine cancel out, which gives me 1 over sine again, which gives me cosecant. Okay, on 36, I've got cosine squared, I'm using x this time, and secant squared minus 1. So a couple of different ways that you could get this one started. Either way, I'm going to need to use a Pythagorean identity, but I'm going to work with this that's inside right here, and I'm going to start by saying that I know 1 plus tangent squared equals secant squared. Oops, I forgot my equal sign. Secant squared. And so if I want it to look like this, I'm going to subtract my 1 over to this side. So I know tangent squared is equal to secant squared minus 1. So I can take this secant squared minus 1 right here, and I can replace it with a tangent squared. All right, that's the only thing I really want to do with a Pythagorean identity. So I'm going to next change things into terms of sine and cosine. So I know tangent is sine over cosine. So I know tangent squared is sine squared over cosine squared. Now I can let those cosines cancel out right there, and that's going to leave me just with sine squared. There's a couple of different ways to work that one. You could have started off by multiplying these together and multiplying these together, and then you'd use your sine squared plus cosine squared equals 1 identity. Your choice on that. All right, the last one for this video, number 37, we're going to take a look at cotangent times secant. So left us kind of with the easy one last. All right, so no squares. So I'm going to avoid my Pythagorean identities, and I'm going to change into terms of sine and cosine. So cotangent is cosine over sine, and secant is 1 over cosine, and I can let those cancel out. Leaves me again with 1 over sine, which is equal to cosecant.